Hello guys, let's solve this problem right here. Now, this looks like a long question, but don't be intimidated because if you just break down the question, you can just jot down what are the given things and you can solve them. So let's see what is given. Two concentric circles, and I've already drawn out for you guys, expanding with increase in radius of inner circle 10 centimeter per second. So let's write that down. Let's say the inner circle is radius 1, so that means dr1 by dt, it's increasing with 10 centimeter per second, and of outer circle it's, let's call that r2, it will be 7 centimeter per second, and it says at the radius of inner circle at 24 cm and outer circle 30 cm. So that means we've given r1 as 24 cm and r2 equals to 30 cm. Is area between the circles increasing or decreasing, and by how much? So we have been given all of these things and we need to find this is the area between the circles. So if the area of the outer circle is O and inner circle is AI, then the area between them is, let's call that A. A is just the area of outside minus the area of the inside. And we need to find the rate. We need to find if it's either increasing or decreasing. So we need to find dA by dt. And let me just drop all of these out and put this information in a nicer way. I'll be back. I'm back. And this is the information that we currently have. And we want to find dA by dt. Well, right here, we can just differentiate both sides with respect to time. And this will be dA0 by dt minus not 0, O, dAi by dt. So, what is the area of the outer circle? Well, we know the area of the circle is pi r square. And here the radius is r2, so it will be r2 square by dt minus, and same for this, it will be pi r1 square by dt. Now, we know that pi is a constant, so it goes outside, and this should be d right over here. So that means it's pi dr2 square by dt. So it's pi and dr2 square by dt. Well, it's kind of like doing the derivative of x square, which is just 2x, right? So it's just 2r2. So it's in fact dr2 square by dt, and this is just the power rule, put the power down, 2r2. But we're not finished yet, because here we're differentiating with respect to time, not radius. So that means we need to use the chain rule and multiply it with the derivative of the radius with respect to time. So this is that dr2 by dt minus this is pi 2r1 dr1 by dt. And here we can just easily solve this now because r1, r2, dr1 by dt, dr2 by dt all are given. So you can just plug the values in. You'll have 2 pi r2, which is into 30, dr2 by dt, which is 7, minus 2 pi into 24 into 10, and let's just quickly compute this. This is minus 60 pi, and since we're doing centimeter per second, this is the unit. So we have a minus. Well, is the answer wrong? Well, not really, because we had the option of either it's increasing or decreasing. And if the rate or the derivative of a function is negative, or that is the f derivative of x is less than 0, this function is decreasing. That is a fact we know, and just by looking at the answer, we also know that the function is in fact decreasing. And how much is at the rate of 60 pi centimeter per second. So that is our answer right here. And you can also see that from the given that the area of the inner circle is expanding much faster than the area of the outer circle. So that means at one point here the area of them will overlap at some point. The area of them will be the same. Let's do that in a future video. So if you guys learned something new, please like and subscribe. Thank you.